how to use our calculator to find areas under the normal distribution, specifically the standard normal distribution, or that on the scale of z-scores centered at 0 with standard deviation of 1. So I'm going to do I already have a couple worked out so I can show you the calculator steps, then I'll close that out and we'll work a few more examples. So there's two types of problems you need to know here. The first is if we're interested in finding a probability, which corresponds to area under a curve. So if you want to find a probability, you're going to use this function on your calculator called normal CDF, or cumulative distribution function. And you just give the range that you're interested in finding the area of. And your calculator, you might notice there's options for means and standard deviations. We're never going to mess with those. Leave them as 0 and 1 because they represent that standard normal z-score scale. You'll also notice in a moment on your calculator that there's normal PDF right next to normal CDF. Be very careful about that distinction and never use normal PDF, only normal CDF. So the first question asks us to find the area below a z-score of 1.52. I've represented the question in two ways. First is a picture. So here's our symmetric distribution. It's a z-score scale, so the center is 0. And my z-score is of 1.52, and I've shaded the area below. I want to find this probability, or area. As a probability statement, I'm finding the probability that the z-score, or that under that z standard normal distribution, is less than 1.52. So on our calculators, we're going to use normal CDF, not PDF, and the range we're going to give is smallest to largest for our interval of interest. So smallest, this distribution goes on forever in both directions, so out to negative infinity, up to positive infinity. So my smallest is negative infinity, and as I move across, I'm stopping at the largest value of interest of 1.52. Now you see in a moment, you don't have a negative infinity button on your calculator. Feel free to just enter some really big negative number, it doesn't matter. And then you should get this final answer. So let's take a look at your calculator. We're going to go the same place we got the binomial PDF and CDF from. So press second, this blue button at the top, and then distribution, which is the vars button over here by the arrows. And you'll notice normal PDF and CDF are the first two options. We're never going to use normal PDF, so go to normal CDF. And some of you might have this populated already with this value. This is representing negative infinity. If you just want to come up with some big negative number to plug in there, go for it to represent negative infinity. That's the bottom of our range. The upper part of our range of interest is 1.52. Then you'll notice the mean and standard deviation have options here. Even later on, when we work with problems that are not on the standard normal scale, leave these as 0 and 1 because we're always going to take the important step of standardizing and putting any observation on the standard normal scale. So again, you must leave these as 0 and 1 for this course at all times. If you try and take a shortcut and change them, you're not going to get complete credit for your work. So working on the standard normal scale all semester long. And then we'll go down and just paste. That's our question here. And if you don't have this type of calculator, it might come up with just the normal CDF, and you have to enter everything in with commas between. So go for that, your big negative number, and then comma, and then your upper, and then you can just close the parentheses. If you don't put 0 and 1, it understands those by default. So press enter. I thought this might be the case. It's good for you to know this error. So I'm going to go to, I know what happened, that minus, that's a minus instead of a negative. It needs to be this negative symbol instead of a subtraction. So now let's try that. There we go, 0.9357 which is what we have written in the notes here. So that's one type of question. If I want to find a probability, use normal CDF and give the region I'm interested in the probability of. The other type of question is if I want to find a z-score associated with a probability. So notice these are kind of backwards of each other. Find a probability given a z-score versus find a z-score given a probability. So the function here in this case is going to be inverse norm, and we'll see that on the calculator in a moment, and the percentage you put in needs to be the area to the left or below. So let's try it out. You're going to go to, so here's the first example, find the 10th percentile. If you remember, percentile means that area is to the left of the z-score. So the area below, I want to find what z-score has 10% of the area to the left of it. So careful when you're doing inverse norm, label it as z so you remember what that function is telling you. This function is giving me a z-score. So the z-score is what I get when I use inverse norm. And when I put in 0.1 for 10%, it's giving me the z-score that has 10% below. And you're going to get negative 1.28, and that makes sense, and according to my picture, 0 is in the middle, so I expect a negative z-score. So let's look on our calculator. We're going to go back to the distribution menu, so second, vars or distribution, and then the third option there is our inverse norm. So press enter on that. Again, you have options for mu and sigma, leave those alone. The area we're interested in is 0.1 because we want 1% or 10% to the left. And then we'll go ahead and paste that. Again, some of you might just have to, when you pull up inverse norm, you might have to populate it yourself. Just put in 0.1 and then close the parentheses. It understands 0 and 1 are the default. And you press enter, you get the negative 1.2815 like we've done here. All right, I'm going to close this now that you see where to find that on the calculator. Again, second distribution, and you'll find normal CDF and inverse norm. So let's practice some more of these. And I'll write the calculator commands as you should on your work you provide. And then you'll know how to verify with your calculator. Keep it out and pause accordingly to check your work. So part B, find the area above 1.52. So I'm given a z-score, so I'm going to use normal CDF. This is the area I'm interested in. So there's my question as a picture. You'll notice it's just the complement or the opposite of what I did here. So I could do 1 minus this to get the answer, or I could just use the calculator again. So I want the probability this time z is greater than 1.52. Get used to writing this probability notation. It's going to serve you well in the future. So that will be our normal CDF. Our lower this time, the smallest number in my shaded region is 1.52. And then I'm going out all the way in this direction to infinity. Again, there's no infinity button on your calculator. Just plug in your favorite really big number and it will be fine. You should get the complement of this, or 0.0643. Let's try a couple more. The area below negative 1. We should be able to answer this one, get a rough idea on our own, because negative 1 was part of our empirical rule. So here's negative 1. Shade all of that in, and just for reference, look at our picture. Here's a negative 1. So if we look at the area below it, should be about 16%. Empirical rule was an approximation, so we might get something a bit more exact this time. So first in probability notation, z is less than negative 1. Notice that I'm using z now instead of x as I have done in the past, because z is that very special standard z-score case that's centered at 0. So we'll do normal CDF. and our smallest value in this case, negative infinity, all the way up to negative 1 is my largest value, and that's going to give you 0.1587, which is great. We expected it to be about 16% from the empirical rule, and it's fairly close to that. Now this last one, what about between two values? We haven't done that before. So between negative 2 and 2. So this is pretend this is symmetric. Sorry, my little sketch doesn't look very symmetric. So remember the empirical rule, if I go 2 standard deviations away, it should be about 95% of the observations. So let's check it out. Between negative 2 and 2. So I want my z-score between these two values. We're going to do normal CDF. And my lower endpoint is negative 2, and my shading goes up to the largest endpoint of 2. And if you work that out, you're going to get 0.9545, which goes right along with what we said from the empirical rule, that about 95% is between 2 standard deviations of the mean. Now, if you're just writing along with me, I encourage you to pause. Make sure you can get these values on your calculator because you will need that skill as you practice some problems on your own. Now, the second type of question we had was we want to find a z-score and we know a percent, so the opposite of before. Be careful in the second example here. It says find the z-score that gives us the top 15%. That means I want to know what is this z that gives me 15% in the top part of the distribution. So we're going to do z is equal to inverse norm. And be very careful, we said our argument needs to be the percent below. So 15% above in the top part of the distribution means below or the bottom part of the distribution has 85%, just using that complement rule. And if you do that, you're going to get 1.0364, which kind of makes sense from our picture. All right, keep your calculators handy. We're going to put all this together in our next example.